Today's video I would like to introduce you a very nice problem of Russian Mathematical Olympiad edition 1990, question number 5. So find all positive integers x and y satisfy this equation. We have 7 to the x as a power of 7 minus 3 is multiplied by 2 to the y equals 1. Okay, so the difference of these two terms equals number 1. So if you would like to give the try to this problem prior getting to the solution, just go ahead, pause this video when you are come back to see the for solution. Okay, now let's jump into the solution. So we have this following equation. So I'm going to divide this one into two cases. Okay, when we have x as an even number and when we have x as an odd number. Let's start when we have x as an even number. If x is an even, let's set x equals to n like this. Okay, so I'm going to take this value of x and insert it into this equation. I will get 7 to the 2n, and also I'm going to bring this number 1 to the left. I will get minus 1, and I'm going to move over this term to the right also. Okay, I will get 3 is multiplied by 2 to the y. So as you know, this one is written on the form of the difference of two squares, so I'm going to factor that. So we'll get 7 to the n minus 1 factor 7 to the n plus number 1 equals 3 is multiplied by 2 to the y. Okay, the problem is number 3. If we don't have number 3 here, we wouldn't have any problem because the whole thing is going to be as a power of 2. Okay, so now since we have number 3 here, which means 3 can divide this one or 3 can divide this one, but we don't know which one is divisible by 3. I'm going to assume this term is divisible by 3. At the end we will find the contradiction. Okay, so by the way of contradiction, suppose 3 divides 7 to the n plus number 1. Okay, if 3 divides 7 to the n plus number 1, according to the divisibility statement, I get 7 to the n plus number 1 equals 3 is multiplied by m. Okay, what is the m? Is a sum of natural numbers. Okay, or positive integer. It will be the same thing. Okay, now I'm simply going to take this value, insert it into this equation. So we'll have 7 to the n plus number 1 will be replaced with 3m. 7 to the n minus 1 it will be replaced with 3m minus 2 because I'm gonna add minus 2 on both sides. We'll get 3m minus 2 equals 3 is multiplied by 2 to the y. I'm simply going to cancel out number 3 from the left and the right. I will be left with m is multiplied by 3m minus 2 equals 2 to the y. Now the equation becomes more easier to solve. So the right hand side of this equation is a power of 2, which means the left hand side of this equation must be a power of 2 as well, which means I will have 2 to the I equals m, and 2 to the j equals 3m minus 2. Okay, so if g must be strictly superior than I. If g strictly superior than I, m must be superior equal to 2. If m equals 1, we'll have equality here. Okay, we'll have 3 minus 2 is 1. Here we will have 1. So m must be superior equal to 2. Okay, if m superior equal to 2, we need to check the m equals 1 because we must have a contradiction for all m. Okay, as a natural number. If m equals 1, if I'm going to replace m with number 1, I will get 3 here minus 2, which is 1. I will get 2 to the y equals 1. If 2 to the y equals 1, which means y equals 0, which is contradiction because we have y as a positive integer. We must have y superior equal to 1. Okay, so let's check when we have m is superior equal to 2, this one. So I'm simply going to multiply this equation by number 3. Then I'm going to subtract this equation from this equation. If I'm going to do that, I will have 3 to the 3 is multiplied by 2 to the I minus 2 to the j. This one 3m will be eliminated. I will get number 2 here. Then I'm going to take 2 to the j as a common factor. We'll have 2 to the j factor 3 is multiplied by 2 to the I minus j minus number 1 equals 2. I'm going to multiply this one by minus sign. I will get minus j strictly inferior than minus I. Okay, so I'm going to take this minus I to the left. I will get I minus j strictly inferior than 0. So which means this exponent strictly inferior than 0. Okay, this one becomes not positive integer. Okay, because we have exponent negative, which means this is not integer. Okay, it's clearly is a contradiction. Okay, so what we have contradicted, we have contradicted this one. 3 not divide 7 to the n plus number 1. Okay, which means 3 divides 7 to the n minus 1, because you have only 2 choices, the either one, this one or this one. Since this one doesn't work, which means this one works. Okay, this one is telling us 3 divides 7 to the n minus 1. Now I'm going to work on this one. Now let's erase this word and continue on this one. So we have 3 divides 7 to the n minus 1, which means equivalent, according to the divisibility statement, 7 to the n minus 1 equals 3 is multiplied by c, where is a c is a positive integer. Okay, I'm simply going to replace this one with this one here. So we'll have the following equation. We'll have 3c is multiplied 7 to the n plus number 1 will be replaced with 3c plus number 2, because as I'm adding number 2 on both sides, I will get this one equals 3 is multiplied by 2 to the y. Now I'm going to cancel number 3 from the left and the right. It's clearly giving me a nice equation here. C is multiplied by 3c plus number 2 equals 2 to the y. So I have ended with this following equation. Now I'm going to discuss this one. This one, it's clearly the left hand side of this equation is a power of 2, because the right hand side of this equation is a power of 2. Okay, which means, so we'll have, as I have before, I will have 2 to the a equals c, 2 to the b equals 3c plus number 2. Okay, so I'm going to do the same job. I'm going to multiply both sides here by number 3. Okay, so this one, it's clearly b strictly inferior than a. Okay, here. So by doing the same job, by doing this equation minus this equation. Okay, so we'll have 2 to the b minus 3 is multiplied by 2 to the a. 3c will be cancelled out. I will be left with number 2 here. So I'm going to take 2 to the a as a common factor. We'll have 2 to the b minus a minus 3 equals 2. Okay, so this one is an odd, because this one is even, minus I is giving us odd. This is even, which means it's clearly e equals 1, because the whole power of 2 is going towards this one. So which means a equals 1. If a equals 1, going back to this equation, so which means I will have 2 to the 1 equals c. Okay, so I found c equals 2, which means I can find b as well. If c equals 2, I'm going to insert the value of c into this equation to find y. Okay, so we'll have 2 is multiplied, 3 is multiplied by 2 plus number 2. I'm going to simplify this one. This one is giving us 2 is 6, 8 is multiplied by 2, which is 16, which is the same as 2 to the 4th, is the same as 2 to the y, which means y equals 4. Okay, if y equals 4, we're going to insert the value of y into the original equation to find x. So we'll have 7 to the x minus 3 is multiplied by 2 to the 4 equals 1. I'm simply going to move over this term to the right. I will get 7 to the x. I will get, this one is giving us 2 to the 4, which is 16. 16 is multiplied by 3, which is 48. 48 plus 1, which is 49. 49 is the same as 7 square, which means x equals 2. If x equals 2, so I found the first solution here. To set this solution, we'll have x equals 2 and y equals 4. Okay, so this one, when we have x is an even. Now let's move on to next case when we have x is an odd. When we have x is an odd, if x is an odd, I'm simply going to move over number 1 to the left and move over this term to the right. I will get 7 to the x minus number 1 equals 3 is multiplied by 2 to the y. Okay, so since x is an odd, this function is a factorable polynomial. So we'll get 7 by factoring out this one. We'll get 7 minus number 1, factor 7 to the x minus number 1 plus 7 to the x minus 2, and so on and so forth until you get 7 plus number 1. Okay, equals 3 is multiplied by 2 to the y. So this one is clearly is number 6, which equals 3 is multiplied by 2, and I'm going to cancel out number 3 from the left and the right. I will be left with this expression. The whole thing, it was multiplied by number 2. Okay, equals 2 to the y. So if you take a look at this expression, since we have x is odd, which means this one is representing the number of terms. The number of terms that I have here is an odd term. Okay, which means from this term to this term is an even terms. For example, if we have, let's replace x let's replace x with number 3, we'll get 7 to the 3 minus number 1. If I'm going to factor out this one, I will get 7 minus 1, factor 7 square plus 7 plus number 1. So how many terms that I have here? Is 3 terms, because I have the exponent is 3. The same thing here, I have odd terms. Okay, if I have odd terms, which means I have this term is an even plus number 1. Okay, the same thing here, from here to here is an even, including number 1 becomes odd. Okay, even from here to here is an odd. Okay, since the whole term is an odd and the right hand side of this equation is a power of 2, which means the whole power going towards number 2. This one is telling us 2 to the y equals 2, which means y equals 1. If y equals 1, which means this term equals 1 in earth, which means you have only one term here. We cannot move on to the other term. So since which means then the exponent must be equal to 0 here. Okay, so we'll have 7 to the x minus number 1 equals 1, which means x minus 1 equals 0, which means x equals 1. Okay, or taking this value of y, which is number 1, and insert it into the original equation to find x. It's simple. Okay, so now I have determined another solution, which is x equals 1 and y equals 1. Okay, so I have ended with these two solutions. So I have done with this problem. If you are interested to watch this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.